everyone here. First thing about my session, I didn't prepare it formally. I've been working on it for the last perhaps 2 months, but the slides didn't come out. What I do want to show you today, I don't think we've shown you actually modules, right? Did you show them a demo? Like,
You've seen it.
Yeah, but
I showed it, yeah.
sort of. So what I want to do today is like give you the entire story about modules, at least from my perspective, and how it looks or looked over the last few weeks. Give you a tour of our marketplace, not the actual marketplace, but what's on it, and show you a bit of the commands or the extensions, the modules that we've worked on. I would like this to be a dialogue of sorts. So if you have any questions, feel free to interrupt me at any time. Just raise your hand and you'll get a mic. If you haven't done so already, let me just make sure that yeah, I'm recording this. All right. So if you haven't done this already, you should go and grab yourself a copy of the latest and greatest in Redis, the Unstable. The Unstable branch actually contains all the module stuff, all the stuff that you need for building and running a module. It's hidden under here, under the SRC folder. If you'll go to modules, you'll be able to get a glean of what modules look like. Of course, this is work in progress, so expect changes on hopefully a daily basis at least. Some documentation, the Hello World example that Salvatore has put together, which I think is brilliant. It teaches you basically everything you need to know about writing a module. It has examples. It shows you exactly what you need to do to use every little thing. So get familiar with it. Start putting in pull requests so we can actually improve it. Find the bugs. There are at least 2 bugs that can be found. And start playing with it. This is basically what we got like 6 weeks ago, I think. It was March 31st when the guys at the labs actually got the first real preview of the modules. We've been getting snippets, gists, like this is what I'm doing from Salvatore, but the actual deliverable landed in our repository on March 31st. And I've been dying to get my hands on it and start playing with it, but sadly, the day afterwards, I had to push out a newsletter. I'm doing a sort of weekly newsletter. I try to make it weekly. And that edition was supposed to go out on April 1st, the day afterwards, and I had to collect a lot of material, process it, publish it. So I had to wait with this gift and unwrap it only a day afterwards. Late at night, after my kids went to sleep, I sat down and like started reading it. It was a weekend, and I spent the entire weekend just like trying to assimilate the stuff. Another challenge for me personally with modules is the fact that you need to be a developer actually to develop them. And the last time I touched a keyboard in the sense of writing a C program, which is what we used, or C code, which is what we use to write modules, at least now, was when the Twin Towers were still up there. So it took me some time to polish off the rust, sort of. I'll show you a couple of things I relearned or learned again or learned for the first time. And Dvir here helped me a lot with getting up to speed with C. And basically, what we tried doing is providing sort of a well-balanced mix of all kinds of modules for the announcement, just to give you a taste of what you can do, and the possibilities are endless. Everybody's been referring to that. I don't know if you've heard it, but it was pure luck that we chose the right theme. We didn't know that modules will be announced back then. It was all the guys from marketing. They just picked up a theme and they hit it spot on. So the possibilities are endless. What you're seeing here is not even the tip of the iceberg. We're working on some very exciting stuff in terms of modules in our labs, and we are looking forward to see what you come up with. So the modules here are the labor of love from the guys at the labs. Some of them are pretty self-explanatory, but I'll go through them nonetheless. Some of them demonstrate some principles which we find fascinating to explore. Let me dive into, for example, one of the first modules here is called Graphics Magic. Iftach earlier mentioned it. So Graphics Magic, the module itself is a Redis module, but Graphics Magic is actually a library that you can download freely and use and link to from any application that you want to develop. And our guys took that library and actually did the binding between the library and the Redis module API, so you can access some of the library's functionality from Redis, like its native Redis. I think as a use case, actually it's a very clever use case. Redis is often used as a cache and often used to speed up processes. It's not unheard of that when people upload pictures or photos to some kind of service, you want to start manipulating and processing these images sometimes very, very fast. So it does make some kind of sense, at least for some services, if you're building the next Flickr or maybe a social network and you want to upload the photo and make a thumbnail out of it very extremely fast and render it and bring it back to the user, this could actually be used for that. But besides the module itself and what it does, I think this module is a great example of how you can just take an existing piece of code, an existing shared library, and with very little effort, and even less now that the modules API is becoming more and more mature, with virtually within a day's work, you can bind a library to Redis. Yeah, sure.
So would modules work with regular Redis commands? For example, tagging, so making a set of images and then putting particular tags to them, for example?
Sure, you can do whatever you want with modules. The possibilities are endless.
Oh,
so it's only up to you. You need to dream it. You need to think what you need to do. You need to design it, of course. But yeah, everything in Redis is there for grabs, and you can mix and match them, and I'll show you some crazy things we did. Not necessarily right in the sense of you shouldn't actually do them, but they're doable. Sure. So any kind of library that's out there, and if you're not familiar with this wonderful website, I'll go back to it again. It's called Github. It has a lot of open source stuff in there. So, and people like us, probably much better developers than I am, have built wonderful software that can be reused, some of it in library form. And you can just pick the library that interests you and virtually effortlessly bind it into Redis, have it run it for you, and get all the functionality from it in Redis and back and forth. It really blows your minds. It opens so many different routes that you can take, so many stuff that you can add. I already have a to-do list just on libraries that I want to use with Redis. That's so long. So this is just one thing you can do with modules. And actually, the first module that I wrote was sort of like that. I took a library, not necessarily Graphics Magic. Actually, the first module I wrote, I scratched because it was a stupid module and didn't compile, and I didn't know what to fix there, so it would compile. So I started from scratch, and the first module I did, I took a library, a Lua library, by the way, and tried moving it to be a Redis module. It was a Lua library for cuckoo filters, which is sort of like Bloom filters. It was the second module I did, and it was under a day I managed to port it, let's say, to be a Redis module. Let's take a look at another module that we have up there. By the way, this is one of the most interesting modules you'll ever see. It's Dvir's text search. It's still pending the formal release in a day or two, the open source. What? The reference is here. We'll just open it. So I'm not going to talk about Redis search because it will take up probably all my time, and I actually need to let Vir do that because I know nothing about that module now. Another very, very impressive module that the guys have come up with is this PAM auth module, which is just a sort of example of things you shouldn't do with modules right now. It's very hackish, but given some of our developers back in the labs are very talented, and more than Redis, they have security backgrounds and so forth. So they found a clever way of actually doing a binary patch inside a module to override Redis's default auth command, something that currently can't be done with modules. You cannot override commands. But we found a way to do it, of course. And basically, they hooked up auth with an external service, this time the pluggable authentication mechanism for Linux. So you can basically do any kind of authentication again for Redis, like the initial authentication that the user does against Redis is actually delegated externally. So it could be used against a directory service or your local password file if you want. So the methods used here are what we would call non-kosher. I don't think this specific module will graduate in this specific form to be certified. We definitely won't want people to start hacking Redis from within across certified modules, but it does show you the strength and where you can take modules to. Let's move on to another one of the modules. And this time I'm going to talk briefly about these guys down here, the RX family. 7 modules all in all. All of them are just the beginning of what we think should be extensions to Redis or an extended set of commands for Redis. Redis has an excess of 190 or almost 200 commands now, and there's always been a balance. What should be a command or a debate? What should be a core command in Redis and what should be done as a Lua script or in some other way? Some of the commands that we have in Redis are asymmetrical. You would expect to have a symmetrical command for them, like I can do lpush and lpop, but why can't I do lpush rpop lpush, but I can't do the rpop lpush, the opposite of that. So what I did is I tried getting inspired from the GitHub repository of Redis. I combed it and looked for interesting use cases. I got quite a few. I haven't been able to get to all of them, but I tried touching some from every place. Popular Lua scripts, some of which I wrote in the past, or the community. There are a lot of commands that Redis could have used or make perfect sense for Redis to have, but it doesn't. So this family of modules is supposed to take care of that. Every topic in Redis will hopefully will get represented as an extended module where we'll develop, and hopefully the community will also contribute. Everything here is open source, so if you have a command that you think merits its place in one of these modules, please feel free to add it. As an example, let's look at RX lists. So RX lists means Redis extended lists, and basically what we're trying to do here is give you a few more commands that have to do with lists. Again, this is a very partial list of commands because we didn't actually have the time to develop everything we wanted to. Lists being the first part of the Redis modules API that we got to play with are actually the most robust. We have a few commands implemented there. Some of them are just a joke, or not really a joke, but maybe a learning experience. So let's see what happened here. You can see that the first command is called lsplice, and if you've reviewed the APIs, the modules API, you would have recognized it. It's lifted straight. It's inlined from the hello world.c file that Salvatore made, an lsplice command, which basically takes a list and splices it into two lists. It's been a very popular request in the past from users. So I thought it merits its place as a real module. It's actually a command that people are using. And then, because I thought I could outdo the master, I said, but why stop there? The lsplice command takes a list, splits it from the end into two lists, but you can actually refer to the head of the list instead of the end sometimes, or maybe you want to flip the list, and all sorts of generalizations that I thought would make a lot of sense. This is actually what brought lxsplice into life, and probably the worst ever command I have ever thought of. It's so unintuitive to use, lots of different options there. I don't know how to use it now. But I've put it there so everyone will learn and be fearful of the expected results. If you need to get into the Redis mode, too much power, and you tend to get dizzy because everything is in your grasp. But this command here, I think, is a great example of what you shouldn't do. You shouldn't overload the commands. You want to keep the Redis spirit, sort of. And this command is a sore reminder, at least for me, of how you shouldn't do that. But a really neat command, on the other hand, is the lpushcapt and rpushcapt. I don't know if you've been trolling the forums like I have, but this probably has been asked for like a gazillion times. And the idea is having a capped list, basically, a list at a certain size, and if I'm pushing to it, great, but once the cap has been reached, I want to start throwing away stuff from the other end because it's not interesting. I want to keep it at this constant size. So, of course, we could do it previously with a Lua script, or even without a Lua script, just call a few like lpush and ltrim immediately afterwards, sure. But this command just does that for you. So it wraps everything. It's happening very fast because it does it almost at Redis speeds, or at Redis native speeds. So a couple of cool commands to have. And the last two, by the way, the lmpop and rmpop commands, are just a variant on the lpop and the rpop command, but unlike them, these accept a count, which basically lets you pop multiple elements each time. So it's not like I've changed the world with these two commands, but I've heard people asking for them, and I could have used them perhaps in the past. Now they're here, and they're here to stay. They're not a part of the core, so they're optional. If you want them, you load the module and use them. Let's see another module, and maybe we'll see it in action, actually. All right, I think this one's kind of cute. I think this is the last module I wrote just before coming here. It has just two commands. They're basically the same in terms of implementation. And, you know, let's take a look at the actual trigger for writing this module instead of like preparing slides for today. Here's a nice site I usually troll. It's called Stack Overflow. I'm sure most of you are familiar with it. And, oh, I'm not plugged in. What a shame. Just a sec. And my browser freezes as usual. Anyone knows how to fix Chrome when it freezes like that? Like you see nothing happen? Oh, cool. Maybe I should ask on Stack Overflow. I think that's me. Yeah. All right, so I was sitting in the office trying to get up to speed like for the conference, and this question pops up. That question, exactly this one. All right, and I'm seeing this question in my monitoring feeds, and this is like perhaps the Googleth time that I've seen this question pop up. How do I delete keys by pattern? People expect that for some reason. I expected that. I don't remember why, but I expected Redis to be perfectly able to do, perhaps because I came from a SQL-ish training kind of world. So I said, why can't Redis do del asterisk or del a asterisk? But it doesn't, and for good reasons called performance. But some of us or some users would rather have it do that. So modules are just the perfect tool for that. I even added the answer just a few minutes ago that the del command doesn't actually do that for you, but there is a Pdl command now in version 3.4. So let's see how we can use Pdl, for example, to, very cautiously, by the way, you don't want to do a del all, it's like flash all, just a lot slower. This is how you use it, very, very simple. So you need a terminal window, perhaps. You need to grab the source, which I think I have. It should be here. Yeah, cool. So if you go and download the the Redis modules from GitHub, you should get something like this. Everything's like stored here as simple C files. You do need to run make in order to use the module, and you need to let the compiler build the shared objects. But once you do that, under SRC, you're going to see that you have all these SO files that you can just start using with Redis. You'll need to grab the latest and greatest Redis. Hopefully I have that here as well. Cool. So I have some sort of Redis server here that does accept modules, and I can actually try and load it. Now, there are a couple of ways to load a module. You can do it in the config file. You can do it from the CLI. During development, what we found out, the easiest way to run a module is just start your Redis server from the command line, give it the module. This is for development purposes. Of course, when you deploy them, you'd probably want to put them in a config file. So let's grab this path here, or actually it doesn't matter. Redis server. So this will start up my Redis server. I'll just pass along this option that says load module, and then I need to give it the full path to the module. So that would sit here, and I will pwd it. Grab this, go here, paste it, and we wanted to use the rxkeys.so module. The important thing to note is that once Redis finishes loading, it does even say that this has been loaded. Sometimes you'll not get that, sometimes you'll get an error. You should resolve it, of course, but right now we have the module up and running. So we just need to run Redis CLI and start using it. It's a new Redis database, so nothing's in the database. And I'm going to set two keys. I'm going to set the eternal foo to bar, and then the buzz to cause. And if I'll do keys again, which you shouldn't do in production, you'll be able to see both of my keys here. So let's try Pdl. Now, most of the modules, or the current convention for modules, is have your module define a namespace. It's not enforced. The namespace is just a string, but call your commands with the namespace dot and the command name. The only exception up until now that we've justified is those missing commands, the extended commands. They should feel like they're real Redis commands, so I'm not going to prefix them. They're just called the way you would expect them. So I'll use capitals to show you that I'm using a real command, but you know, Redis doesn't really care if it's capital or not. Pdl. Now, Pdl, if you'll go back to the documentation page, you'll see that Pdl where are you, Pdl? Actually gets a pattern. The pattern is a POSIX extended regular expression. You may ask why. The simple answer is that that's what's in C. It was the easiest thing to grab. So I'll just call Pdl, and what I'll do now, I'll try to delete everything that begins with a B. You do that by indicating that you're starting from the beginning of the line. You give the character that you want, any character afterwards, wildcard, and hopefully I just deleted the stuff I wanted to. And if I'll run keys again, yeah, B was deleted, foo remained, which is kind of awesome, I think. By the way I do it internally, I'm running the scan command. So I'm scanning the database inside my module. I'm keeping the cursor. Whenever I get responses, I match them against the regular expression that the user provided me. If it was matched, I delete it. If it wasn't matched, I continue. I just scratch it and move on. The other command, by the way, that this module provides is called pkeys, which does the same thing. It just iterates on the key space, but returns to you keys according to a specific POSIX regular expression rather than Redis's regular pattern matching, which are simple and sometimes not just enough. So these are like two of the commands in pkeys. But there are other modules out there, in here. And the next module I actually want to talk is another RX family, but it has just one command. It was the one before last module that I got to wrote just because of time constraints. But this was the funnest one, I think, to write. It has a single command. It's called the Geo Cluster Command. I'm sure you've heard that Redis has some geospatial abilities right now in version 3.2, and one of the things that we've been doing is researching and seeing how we can leverage on what Redis offered to provide even more functionality. I've done a little project in Lua just before modules came out, in which I explored different facets of the geospatial indexes and how you can leverage on them to provide even more functionality like polygon matching and real-time tracking, stuff like that. Of course, with modules, I am planning to port the entire thing to modules, and Josh Baker, is he in the audience here? No. Josh Baker is also going to do something very interesting with geospatial. But for the first command in the Geo module, I chose clustering. So clustering, Iftach gave a great one slide demo. I didn't prepare it, but to show you what Geo clustering does, I'll just open the official paper and show you how it looks. So I found this algorithm, Google found it for me, of course, which describes a very, very cool algorithm called DBRS. Which stands for, of course, density-based spatial clustering method with random sampling. So intuitive. And scrolling down, it shows you exactly what it does. It basically takes a bunch of points on Earth and starts clustering them together. And this is what it knows how, and this is what it does. It knows how to ignore noise. Noise is like points that are just scattered around your cluster. So it does know how to cluster things and ignore the points. It does know how to grow the cluster and snake it. So the cluster, some algorithms only find, like in a snake like that, a couple of clusters and don't know how to connect them. This algorithm actually does that. And a few more tricks up its sleeve. It even compares it, there's a comparison of that algorithm to another very popular clustering algorithm. I won't go into that. If we'll scroll down a little, this is the fascinating part, of course, the algorithm's description, which fits into a neat half page. I stared at it for so long. This is the algorithm. So I won't bother you with reading the entire thing and how it works, but the thing that really caught my eye when I was looking for something cute to do with geospatial is the fact that if you look at this algorithm, you can see that, for example, it has this has intersection at line 11. So whenever, as a Redis geek, whenever I hear has intersection, immediately I think about Redis's family of inter commands. So that looked very promising. Also, there is a merging function here that basically takes two existing clusters and merges them together, which kind of really which translates very well to a union in Redis. So this module here is actually a good example of how you can take Redis's existing data types, in this case sets or geosets, and use some of Redis's existing capabilities mixed with some other logic to build something wonderful like this clustering thingy. I can even run just show you how it works. Where is that? Where's the marketplace? Oh, left it here. So this example should actually work if and only if I'll add my module to it. I'll run my model. So let me stop the server, change this to RxGeo. Cool. And then start pasting in the example. So the first thing we want to do is create our data set. I'm creating a very synthetic example. I'm starting to populate a sorted set with a bunch of points, 10 points actually, 2 clusters. This is the first cluster. I called it using the descriptive names of C1 to designate it the first cluster, and then in the example here, I'll just copy the second set of points to the same geoset. And so now we have a geoset with 10 points. We should have 1. All right, this one has 10 points scattered in space. And if I run the command as it's written here, it should work. Yeah, F12. Here we go. So what this did is actually it ran through the space through the geospatial space. The algorithm calls for random sampling of unassociated points. Like every point can either belong to a cluster or not. So you go over all the points and you randomly select the next point that's unassociated. Then you look for its neighbors, and then you do some sort of merge if it's too close to an existing cluster, and so forth. So this is what it did, and it sped out. If I'll do keys now, you'll see that basically this command is very naughty. It creates keys. This is, I think, the first command that I ever wrote that creates keys in Redis purposefully. And I had this geoset key, and this command created 3 additional keys. One is just a list, the CL, with a very descriptive name, CL, of course. The list is used internally in the algorithm to keep track of the clusters that I'm creating, but I left it, if anyone wants to use it, he can use it after the algorithm finishes. So it just contains 2 entries, the names of the keys in which the new clusters are sitting in. So I have 2 clusters, DBRS geoset 1 and DBRS geoset 2, and if I'll do a Z range, for example, on one of them, you'll see that hopefully this has the right cluster in it, one of the clusters, Z range. So you can see that all the points that I wanted them to belong to one of the clusters actually fell into this cluster. So what this algorithm does is just geo-clustering. It should be expanded. We'll add it with more capabilities like showing you the size and maybe rendering it on a map or something. Very, very useful, very, very cute. And again, what's the neatest thing about it, and you can review the code, it just calls Z-union and stuff like that. By the way, I didn't use Redis's intersect because I just wanted to know if there's one point intersecting in an existing cluster with my point. I didn't need the entire intersect, so I did it manually. I'm actually scanning, iterating over the sorted set using the Redis API, the Redis modules API, and breaking as soon as possible once I found a single match. So it was a cool trick or a cool exercise to do. This is Redis Geo. The last module I wanted to touch on, well, there are 2 modules and 10 minutes, so let's do it quick. There's the Redis Bloom filter. So Bloom filters have been on the to-do list and the wanted features list from Redis for a long, long time. Bloom filters are actually pretty unimpressive when you look at them. Everyone wants them, but when you start thinking about them, They don't really fit very well into Redis. I guess I'm a spoiled kid because Redis really turned me into a data structure user. I sort of expect my platform to provide me the convenience of Redis data structures. One of the conveniences of Redis data structures, I don't know if you've ever given it any thought, but is the fact that you don't have to create them. You don't have to declare them implicitly. There's no create pattern in Redis. It's actually an anti-pattern in Redis. So if you want to start using a list, you just start pushing into the list. You don't have to create it before you push it, or a sorted set or a string, it doesn't matter. Everything just exists the minute you start using it. With Bloom filters, on the other hand, the challenge is, and a lot of these kinds of data structures, you have to declare them because they have to be initialized with some defaults, some parameters. With Bloom filters, for example, you have to explicitly say this Bloom filter is gonna be this big, and Bloom filters also have a property of associated error rate. So you need to say, I want the error rate of this Bloom filter to be this and that. And this doesn't really translate well to the Redis way of thinking of I'm just starting to use this data structure and it's there. So this was a bit challenging. Also, the Bloom filter here is quite big in the sense that if you use the defaults, you get a 300 or 400K key after you just initialize the filter, or even added it. You don't need to initialize it, just add one element, but one element in the filter and you, bam, you got 400Ks. It stays that way for a while, but an empty filter sort of is a 400K filter. So it kind of goes against my Redis beliefs. But it has been a very cool exercise. Also, what I've done here, I've taken an existing library. It's called the Blooms. It's a Bitly library that they've left in GitHub. They're not maintaining it anymore. And it basically does Bloom filters, only it does them over regular files. The challenge here was ripping all the file descriptors out of the heart of the beast and then mapping the entire data structure to a Redis string using Redis direct memory access, which I kind of bumped all the way. All my pointers were slipping, segfaults and stuff like that. But eventually it worked, and it works. Very, very cool data structure. I'm looking forward to actually doing it again, me or someone else, hopefully, in a more effective way. Yeah. In the Bloom filters, what I did is we mapped the data structure, a C data structure on top of Redis strings. There's a way to ask Redis for direct memory access to a string, which is basically you can allocate space, memory inside of Redis and use it just as you will in your program. So this is what we've done. It's like a custom data type, although the current API doesn't allow custom data types yet. It should allow them soonishly, but you can still get away with it by using string DMA, for example. The last module I wanted to show you is a very cool module. It's called the Top K module. And the Top K module is an interesting beast. It belongs to the same kind of family of Bloom filters, count min sketches, hyperlog logs, all that good stuff that allows you basically to look at a stream or an obscenely large amount of data and get some useful information from it without having to store all the data along the way. So Top K tries to answer the following question. Given the stream of elements that I'm seeing, a stream of observations, maybe these are IP addresses, maybe these are URLs, session identifiers, you name them. Given that stream, I want to keep track of what I'm seeing, and at any given point in time, I want to be able to answer what are my top K, top 5, top 10, top 10,000 elements that I've seen up until now. The trick is I don't want to keep all the elements I've seen up until now. I just want to know what are the top Ks. I want to limit it. So that's the challenge. There's a paper, or rather it's, I think it's, if I'm not mistaken, it's session notes from one of the from a university, which talks about the algorithm. The algorithm itself is fairly simple and translates really, really well to Redis's data structures, existing data structures, and the module's capabilities. So I do want to dive in just a little bit into this one with more details. Let's see it in action first, then we'll see how it works internally. So just like any other module, if I want to use it, I'll need to build it. Luckily, I have it here, so let's go to top K. Same directory structure, basically. Sorry, you've got your, you downloaded it from GitHub. We've provided you with a make file, so all you need to do is run make, and barring any issues, it should compile. Then to actually use it, you go ahead and load it from your directory. Cool. So my module is in place. Where's my CLI? Here's my CLI. So this module is fairly simple to use. Just like any Redis command, you don't need to declare it, to declare your data structure ahead of time. You just start using it with the top K period add command. It accepts two mandatory arguments. The first is a top K key, so you just give it a name. It's going to be a sorted set. The type of this key is going to be a sorted set. And then you need to give it the K, your cap. So in this particular case, either you give it a K that looks like a number, maybe 5, or you give it, or you give it 0 to signify I don't want to decide on the K right now, just keep growing with every observation. So top K 5, and then you just start feeding it observations. If I'll feed it A, B, C, D, and E, I should get back the cryptic 5, which basically means I've added 5 elements to this set. And you can actually do a Z range on T from 0 to, from 1 to -1. And you'll get all your elements back. They're there. I'm keeping 5 elements. You've asked me to keep the top K 5 elements. You can even call them with scores, and you'll see the matching scores. This is actually the number of observations per element that I've seen up until now. Let's continue, and if I'll do the same command, well, let's just run it on A and B. So right now I'm getting 2 more observations for A and B. The reply is 0 because I've seen them earlier, so right now I only changed something internally. I didn't add new observations. You can see that A and B got bigger scores. And I can keep on going with A and B, but let's just add everyone one more time. And right now what's going to happen is this pesky foo is going to come in. Now foo won't have any space left in this top K structure. It already has 5 elements. That's my K. So something is going to happen, something else. I got back 0. 0 means I couldn't add this. No change has been made. Only scores have been perhaps adjusted. And if I look at my top K set, you'll be able to see that everything remained just as it was. The reason is that foo is too new. It's too low. Everyone is higher than 1 observation, so I can't really evict anyone from there because foo I've seen only once. All the rest I've seen either twice or thrice. So the first time I tried entering foo, it didn't make the cut. But if I'll try adding it again, its frequency will be 2, theoretically. So it should compete with one of the existing elements that has the same frequency, that being C, D, or E. Let's see what happens. So the filter now tells me, or the top case structure now tells me, listen, I managed to kick out someone. I don't know whom, by the way, because I'm using random sampling here, but if I was lucky, foo made it. If I wasn't lucky, it didn't make it, but it will make it the next time for sure, because when I'm trying, actually, it will always make it. I make sure that in this case it will make it. So you can see foo. You can see that it has the same frequency of 3 like the other guys. Right now, I've seen it 3 times. or rather it doesn't have the same frequency. It looks like it has the same frequency. What I haven't shown you right up until now is a little element that I'm keeping hidden away inside the same data structure. So there's actually another element here that I'm coding by hand inside the module. The first element, it has a score of 0. I'm keeping it there. And this is a meta element. It contains all sorts of interesting data about the data structure. Specifically, it only keeps one field, track of one field currently, or two fields. Let's see them. I've added this command. It's called topk debug show t. And this one goes just to the meta element that is encoded here. Yeah, I've got 2 seconds. Time is froze. I don't have 2 seconds now. Anyway, the code is out there for grabs. If you want to ask me questions about modules, please feel free. We're pushing out material every day about it. Dvir has put together just today a lovely guest that I want to promote. Already on the second place on Hacker News. Everything you need to know in 15 lines of code, and we'll try to optimize that for less to get started. It's really easy, and it's really fun. I'm sorry I don't have time for questions. I'll be here. Thank you very much.